Today, I'll hopefully help you gain a new perspective when thinking of three very common terms in physics: matter, mass, and energy. Even though you may know these terms having definitions making it sound like en- energy and mass are just properties of matter, fundamentally matter and energy are the same thing and they both have mass. Matter is just a very condensed form of energy. As an analogy, you can think of energy as being like water vapor and matter like being ice, where they both are the same thing, but they look different and ice is much more condensed. This is expressed in Albert Einstein's famous equation E equals mc squared. Matter contains so much energy that you have to multiply it by the speed of light squared to find the energy. The vast differences in amounts of energy to matter is why we generally do not notice that energy and matter are the same thing and that energy has mass as well. Basically, the only case we notice this on Earth is during nuclear reactions where their energy is released is enough to make a noticeable impact on mass. Adding or subtracting energy always has changed the mass, just as heating a glass of water, but the mass difference is far too small to notice. Even though scientists do know that matter and energy are the same thing and both have mass, even many pure physicists say that energy, just as light, is massless. They say this because there are multiple different ways to measure mass. One type of mass is rest mass, is a measure of the object's inertia when it is not moving compared to the person measuring it. Another is relativistic mass, which is a measure of the object's inertia even when the observer and object are moving compared to each other. You may be wondering then, why some energy such as matter has rest mass while energy such as light does not? You have to go to the particle level to understand this. Everything is made of particles that cannot be broken down farther, called elementary particles. These particles are created using energy to excite their own quantum field. All elementary particles have their own quantum field. Some of these particles interact with another quantum field called the Higgs field, which has an acquired rest mass and stops them from going the speed of light. Other elementary particles, such as photons that make up light, do not interact with this field and therefore have no rest mass, and their energy is stored by moving at the speed of light. Going to the larger level of atoms, which all normal matter is made of, it consists of electrons, protons, and neutrons. Electrons are elementary particles, which cannot be broken down farther and have a rest mass. Protons and neutrons, which are not elementary particles but are instead composed of three elementary particles together, make up most of an atom's mass. When you add the individual masses of the elementary particles that make up the protons and neutrons together, you get a much smaller amount than the total mass of the proton or neutron. The missing mass comes from the high speeds of the particles and the strong nuclear force between them. Their speed can add rest mass and not just relativistic mass because the particle as a whole is not moving. Knowing how matter is actually energy can get you a more complete understanding of physics at a fundamental level.